10 raised to the power 25 minus 7 is divisible by 3. We have to calculate the remainder. This is divided by 3. We need to calculate the remainder. So we need to find out the remainder. We know if we write 10 raised to the power 25, 10 raised to the power 25 is 1 followed by 25 zeros. So as 10 is 1 followed by a single zero, 10 is square is 1 followed by double zero, 10 raised to the power 25 will be 1 followed by 25 zeros. Minus 1, if I write 7, I am writing as minus 1 minus 6. So it is, I am writing 10 raised to the power 25 minus 1 is, this will be 9999. How many digits will be there? There will be 24 digits in it, all 9. 999 will be written 24 times. 999 will be written 24 times. There will be 24 digits in it. So 10 raised to the power 25 minus 1 will be 999 with 24 digits. So it is surely 999 is surely going to be divisible by 3, right? And we are left with minus 6, which is also divisible by 3. This number is going to be divisible by 3 and this number is further divisible by 3. 999 written 24 times is surely a multiple of 3. This number is a multiple of 3, so it will be surely divisible by 3. This is also divisible by 3. Both the numbers are going to be divisible by 3, so their subtraction should be always divisible by 3. Hence, in this particular case, the remainder will be 0. Remainder will be 0. This is a multiple of 3. This is a multiple of 3. In both the cases, they are divisible by 3. So their remainder will be 0. Both the numbers are thoroughly divisible by 3. If they are divisible by 3, so when this complete number is going to be divisible by 3, the remainder will come out to be 0. One way of looking at things is this. Also we understand by remainder theorem, which we discuss, that 10 can be written as 1 mod 3. We can write 10 as 1 mod 3. 10 when divided by 3, the remainder will be 1. 10 when divided, let's see an alternate approach. By remainder theorem I am explaining it. 10, so this is 10 can be written as 1 mod 3, and any power of 10 for that matter will be equal to 1 mod 3. Number remainder mod divisor, any power of 10 will be also equal to 1 mod 3. 10 raised to the power 25 will be equal to 1 mod 3. So we have here 10 raised to the power 25, the remainder is 1. 10 raised to the power 25, the remainder is 1. And 7 can be also written as 1 mod 3. 7 can be also written as 1 mod 3. Now the rule simply says, if we can add the numbers, we can add their corresponding remainders. If we can add the numbers, we can add their corresponding remainder. If we add them, or if we subtract them even, then we can subtract the corresponding remainders. If we add, subtract, multiply the numbers, we can subtract, add or multiply the corresponding remainders. So here in this particular case we are subtracting it. So 10 raised to the power 25 minus 7 will be equal to, subtracted 1, this is 1 mod 3, 1 raised to the power 25 is 1, and 1 minus 1 is 0 mod 3. Such a high number is divisible by 3, the remainder is 0. Number can be written as remainder mod divisor. So we can easily say 10 raised to the power 25 is equal to 1 raised to the power, because 10 was 1 mod 25. So number any power, natural number power, number any power, remainder same power will be equal to mod divisor. 10 raised to the power 25 will be 1 raised to the power 25, and we know 1 raised to the power 25 is 1. When the numbers are subtracted, the remainders is also going to be subtracted. So this huge number when divided by 3, the remainder is 0. This is another way of looking at things. Another way of looking at question number 5. Another way of looking at question number 5 can be equal to, we have an minus bn will always have a factor of a minus b. N is any natural number. If n is any natural number, an minus bn will always have a factor of a minus b. A minus b will have a factor of a minus b. A square minus b square will have a factor of a minus b. A cube minus b cube will have a factor of a minus b. An minus bn will always have a factor of a minus b. We are doing this question by the third way, how we can solve it. This is an alternate approach as well. I have already given you 2 methods how to go about it. Also, 10 raised to the power 25 minus 7 can be written as 10 raised to the power 25 minus 1 minus 6, which can further be written as 10 raised to the power 25 minus 1 raised to the power 25 minus 6. Now an minus bn will always have a factor of a minus b whenever n is a natural number. So it will always have a factor of 10 minus 9 and into some term minus 6. So it is 9k plus 6. Now let us understand what I mean to say is, an minus bn will always have a factor of a minus b whenever n is a natural number. For any natural number, it will hold true for any natural number. So we have 10 raised to the power 25 minus 7 can be written as 10 raised to the power 25 minus 1 and minus 6, which can further be written as an minus bn. An minus bn will always have a factor of a minus b whenever n is a natural number. So this term will have a factor of, this term is surely having a factor of 10 minus 1. This number will be surely divisible by 9. If this number is going to be divisible by 9, if this number is going to be divisible 9, it is surely going to be divisible by 3, and this is also divisible by 3. Both the numbers are going to be divisible by 3, so their difference is also going to be divisible by 3. Our question is, this complete number when divided by 3, the remainder was, so this is a multiple of 3 as it is a multiple of 9, and this is already a multiple of 3, so their difference is also going to be a multiple of 3. So it is purely divisible by 3, the remainder will be 0. This number, the remainder will be 0. So we have seen one approach for the problem was from remainder theorem, mod point of view, and another approach was when I've written it as this number as 9 followed by 999 24 digits, which is a multiple of 9, which in turn is a multiple of 3, minus 6 is also a multiple of 3. So that was the second approach, and the third approach is this, an minus bn will have a factor of a minus b. This will be divisible by 9, and so it will be also divisible by 3. If the number is divisible by 9, it will be also divisible by 3, and this is already divisible by 3. Hence the remainder will be